Okay, now we solve question number 3. Look at the question number 3. ABCD is a square and A 2, 3 and C minus 6, 5 are opposite vertices of that square. Find the equation of BD. We have to find the equation of BD. So before starting the solutions, let us discuss some basic concepts about the diagonals of the square and perpendicular bisector. Look at this, the line PQ, okay, and suppose the line MN bisect PQ perpendicularly, bisect, that means that divides, MN divides PQ at point O perpendicular. So what we call MN is perpendicular bisector of PQ. Okay, it means that means MN is, that is MN is perpendicular to PQ and O is midpoint of PQ. Okay, this is the meaning of MN is perpendicular bisector of PQ. And also we have to find the equation of MN. To find the equation of MN, which is perpendicular to PQ, first we find the slope of MN. Okay, we know that the slope of MN times slope of PQ equal to -1. That means you can write that M2 into M1 equal to -1 because they are perpendicular to each other, and the MN passes through the midpoint of PQ. This is another consequences of this result. Okay, so to find the equation of MN, what we do, we use this relation to find the slope of MN, and to find the point through which that MN passes, we use midpoint formula because the midpoint of PQ, O is the midpoint of PQ. So after finding the slope and the point, you can find from this M, from this x1 and y1, and then use point slope form. And that point slope form is y minus y1 equal to m times x minus x1. Okay, so this is the procedure to find the equation of perpendicular bisector. So what we see here in the case of a square, okay, let us make it a square. So this is MN and it is Q. Because it is a square, so PMQN is a square. Okay, then look at it, the same result. MN is perpendicular bisector of PQ, or PQ is perpendicular bisector MN. In case of a square, all these are equal because the diagonal of the square bisect each other at right angles. That means MN is perpendicular bisector of PQ or vice versa, and same result, and we can find the equation of either of the diagonals. It depends on the given conditions. Okay, so if it is a square, and same concept can be used to find the equation of diagonal of rhombus. Okay, in case of rhombus also same thing. This is a rhombus, say P, M, N, Q. In case of rhombus also, MN and PQ are perpendicular bisector of each other. So, but here this part is not equal. Okay, all part is not equal. PO is equal to OQ and MO is equal to ON. So the same result we can use, okay, to find the equation of the diagonals of rhombus. So in case of rhombus, rhombus, square and perpendicular bisector. Okay, all in these conditions we use the same procedure. Okay, perpendicular, they are perpendicular, we find the midpoint and slope condition, condition of perpendicular, we find slope and we find the midpoint, okay, and use point slope for. Okay, now we start the solutions. So look at here, solution of 3. So ABCD is a square here. Square, and A is 2, 3 and C is minus 6, 5 are opposite vertices. It is given in questions. Okay, look at this diagram. So what is this? This is a square. So AC is perpendicular bisector of BD, or BD is perpendicular bisector of AC. So therefore you can write BD is perpendicular bisector of AC. Okay, this is the given condition, and BD is a perpendicular bisector. So now we find midpoint using midpoint formula. Midpoint of AC is equal to x1 plus x2 by 2, y1 plus y2 by 2. So here x1, y1 is the coordinate of A and x2, y2 is the coordinate of C. Okay, initial point, the coordinate of initial point is x1, y1, the coordinate of terminal point is x2, y2. So coordinate of x coordinate of A is 2 and x coordinate of C is minus 6 divided by 2. Y coordinate of A is 3, y coordinate of C is 5 divided by 2. So on simplifications you will get minus 2, 4, and this can be considered as a point through which the diagonal passes. Okay, so this is, say, x1, y1. Okay, now we find the slope. Oh no, we solve it here. We solve it here. Now slope of AC, say it is M1 equal to y2 minus y1 by x2 minus x1, because the 2 points are given, and y2, that is 5 minus 3, y1 is 3, and x2, that is minus 6 minus 2, and this gives 2 by minus 8, and this is minus 1 by 4. Okay, and then after this, what we write here, Since AC is perpendicular to BD, look at it. BD is perpendicular bisector of AC. That means BD is perpendicular to AC. Now let slope of BD be M2 equal to M. Then M1 times M2 equal to minus 1. Okay. And what we get? The value of M1 is minus 1 by 4 times M2 is M minus 1. And this implies that M equal to 4. Now we have got the slope of BD. And point is also given here. Okay. So this part is the process to find the slope, and this part is the point through which the diagonal BD passes. So we have got x1, y1 and the slope. So from, okay, you write here from here, from point slope from y minus y1 equal to m times x minus x1, or y1 is 4 equal to 4 times x minus the x1 is minus 2. So y minus 4 is equal to 4x plus 4 to the 8. Okay. So 0 equal to 4x minus y plus 4 plus 8. Therefore we have 4x minus y plus 12 equal to 0, which is required question of BD. This complete the solution of 3. Okay, when we transpose the whole quantity, whole terms to the other sides, then there is no change in sign. Remember that point. Okay. Now we solve the question number 4. You look this solutions. Midpoint, slope, okay, and then point slope form. Okay, now we start the solution of 4. So 4. So here also the same. ABCD is a square. Is a square. ABCD is a square, and what we have given? Equation of BD is x minus 3y equal to 2. So therefore you can find the slope of BD, that is M1, and equal to minus coefficient of x divided by coefficient of y, and this equals minus 1 whole divided by minus 3, and this is 1 by 3. Slope of 1, slope of BD. Okay, what we have to find? We have to find the equation of AB and BC. Look at this diagram. AB and BC and the equations BD. Okay. And the coordinates of B is 5, 1. We have given that. And now look at here. AB is perpendicular to BC, it is 90 degree, and BD is a diagonal. That's why BD bisect the angle ABC. So this angle becomes 45 degree and this also 45 degree. So what we see here, the angle between the AB and BD is 45 degree. Okay, and the angle between the side AB and BD is 45 degree. And same in the case of BC and BD. So this line and x minus 3y equal to 2 and AB, that is intersected at 45 degree. So we can use the formula tan theta is equal to plus minus m1 minus m2 divided by 1 plus m1 into m2. From this we can get the slope of AB and BC. Okay, so here slope of AB times slope of BC becomes minus 1. So if one of the slope is A, then another slope is minus 1 by A, or vice versa. Okay, or if one of the slope is minus A, then other slope is 1 by A. Remember this. Okay, in this case always, so from these relations we have the two values of m slope, and one is A and another is minus 1 by A, or minus A and 1 by A. And so because AB and BC are perpendicular, so their slope is product. So either of the equations represents AB or BC. So what we do? Now we find the slope. Okay, now we write that angle between AB and BD, that is theta, is equal to 45 degree. Why? Since BD bisect angle ABC is equal to 90 degree. So the half of 90 is 45 degree. And the angle between AB and BC. So suppose slope of AB. Okay, slope of AB, that is m2 equal to m. Okay, then we get that tan theta is equal to plus minus m1 minus m2 by 1 plus m1 times m2, and the value of theta is 45 degree, plus minus the value of m1 is 1 by 3 minus m2 is m divided by 1 plus m1 times m2, that's 1 by 3 times m. Okay, then the value of tan 45 degree is 1 plus minus, by taking LCMs, 1 minus 3m divided by 3 whole 3 plus m divided by 3. So the 3 and 3 in the same, they are same quantity and they are in this denominator too. So we can cancel by 1 times. So we get by cross multiplication 3 plus m is equal to plus minus 1 minus 3m. So we have a two sign here, one plus, another is negative, taking positive sign. So we get 3 plus m equal to 1 minus 3m. So plus plus plus, plus minus minus. So this gives the value of m equal to minus 1 by 2. You can do the simplifications. The simplification is left as an exercise. You find it. Okay. The value of m is minus 1 by 2. Again, taking negative sign. So 3 plus m equal to minus 1 minus 3m. So minus sign, minus plus, minus 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 plus. So we have 3 plus m equal to minus 1 plus 3m. And on simplification you will get the value of 3m is equal to 2. Okay, so we have two values of m, minus 1 by 2 and 2. Look at it. Slope of AB and slope of BC are product of the is minus 1. So minus 1 by 2 and 2 is minus 1. So what we see, so these two slopes are either the slope of AB or BC. Okay, so slope of AB may be minus 1 by 2 and slope of BC may be 2. So now finally we arrive at the solutions. Let us see. Now question of the sides AB and BC are given by y minus y1 equal to m times x minus x1. Okay, so the point the line AB and BC passes through 5, 1. Then we get y minus 1 equal to m times x minus 5. Okay, now we have two values. When m equal to minus 1 by 2, y minus 1 equal to minus 1 by 2 times x minus 5, or y minus 1 by cross multiplication of 2 equal to minus x minus minus plus 5. Okay, or you can write that x plus 2y minus 2 minus 5 equal to 0, or x plus 2y minus 7 equal to 0. And when m equal to 2, we get y minus 1 equal to the value of m is 2, x minus 5. And then y minus 1 equal to 2x minus 10. And this gives, okay, 2x minus y, 2x minus y minus 9 equal to 0. And the simplification is left as an exercise. You solve this. Okay, hence the required questions of AB and BC are x plus 2y minus 7 equal to 0 and 2x minus y minus 9 equal to 0. This is the complete solution of the question number 4. So why this is, AB and BC, we have seen in the diagram that AB and BC, they are perpendicular. So these are the equations of these two perpendicular sides, AB and BC, and they both passes through 5, 1. Okay, so in such kinds of problem, you have to find the angle between the diagonals and the sides. Okay, and this is 45 degree, and use this formula. You will get the two values of m, and the two values of m are the slope of the adjacent sides of that square. Okay, in this way we can solve this type of problem. Okay, thank you for watching this video. We'll see more videos in coming days also. Thank you.